Yes, you are. Hi. Hello. Can you tell I've updated my mic? Is it too loud? I'm using the previous mic that I lost and it's back to me. Yay. Hi. Hi, Coffee. Good morning on my... Yay! I'm glad. Thank you. Hi, Ju. How did the stream go yesterday? Did things multi-thread and network or... Thank you. Yes. I love this microphone. I'm very sure that I bought it before COVID. So yeah, we go back. And please feel free to hit the hay. Struggling to understand means you are halfway there. Glad you had fun. Okay, background noise. Alright. I mean, maybe the car is passing by, but... Wow, the resting noise is so loud. Wait, I know I've made some, let me roll back some changes I made. I think that would help. Okay, that should be a bit lower and still background noise, but lower background noise. Because yeah, the resting, when I'm quiet, I see it being really loud. I'll think about it. Okay. Thank you. I'll look into that. I did not know that. I will look into that. Should I? Okay. Alright. I'll check my normal yes, what you said. I'll check my normal noise. Can you hear that bird? Okay. There's life around me, that's for sure. Okay. Oh, okay. Alright, thank you. Yes, cute bird noises. Oh no, I don't have bird headphones on. I have bear headphones on. Okay. Wow. Okay, so it does the auto muting for you, which is very useful. I mute when I like eat and stuff, so thank you. That is really useful. Hello. Learning time. Okay. I'm very sure that you will also hear other bird noises just chirping, because it's early in the morning and we have trees, so good combination to hear birds. Now, do I want to start with HuggingFace or do I want to start with Carnegie Mellon University? Each time I say Carnegie Mellon University, I feel fancy. I don't know why. No, that's not where I was. I'm very sure that's not where I was. Well, maybe I... Really? No, we were here. Okay. I think I'm gonna go with HuggingFace because yesterday I was still struggling with whisper stuff. And I think how far I've gone with this course has proven to be useful without any actual outcomes, I mean any useful things that I've done yet. Just that I understand the code that I'm reading better. And I do realize that I need to reread that the thing that, because I have gone through it before one more time, but what was it? The how to sorry, this is taking me longer than it should. How to fine-tune whisper. That one. I went through this once, tried to just run it as is on a local setup that I have access to. And then, because when I tried to run it on Colab, it actually failed, as far as I remember, even though this is supposed to be run on Colab. Maybe even there is a part that it's saying if you're running on Colab without paying it, you can like make things. There's a part when you go to the Colab, it says change these numbers, it should make it easier and all that. Still got nowhere with it. I mean, I'm just happy that it exists because yeah, but I was like, you know what, I'm gonna start with just using the API, and then I'll go to the fine-tuning part. Yes, so now this is supposed to help us with fine-tuning a model with the trainer API. Actually the trainer API is actually being used here as well. Yep. And then you say trainer, bring that train. So do let me know if there's a voice inconsistency between me and what I'm playing, okay? I don't think there will be, but let's just check.
The Trainer API. The Transformers library provides a Trainer API that allows you to easily fine-tune Transformers models on your dataset. The Trainer class takes your datasets, your model, as well as the training hyperparameters, and can perform the training on any kind of setup: CPU, GPU, multiple GPUs, TPUs. You can also compute the predictions on any dataset, and if you provided metrics, evaluate your model on any dataset.
Okay.
You can also handle final data processing, such as dynamic padding, as long as you provide.
The way he moves, he looks AI generated. This is from 2021. I don't know if we had the capabilities. I know. Yes. I think he probably has like a small window of movement because of the cropping. Maybe it was like he was told. Oh, actually, it's most likely he's using something like PowerPoint, where you can crop yourself. Have you used that? You can crop yourself to one side. I really like the feature. Have not used it because it just feels weird. But so I'm guessing that he had limited movement, right?
And if you provided metrics, evaluate your model on any dataset.
I do believe it's the camera's fault as well. It makes it, you know, this style of compression where pixels update and you can actually see it happen. So that's what it also looks like.
You can also handle final data processing, such as dynamic padding, as long as you provide the tokenizer or a given data collator.
Yes, you really didn't know? Well, PowerPoint has this thing. Let's look for it. Oh, I don't know. PPT insert camera feature. I'll just show you. So you have like your face, and you can change whatever shape you want, and then you turn on the camera and there you are. And there are like really cute shapes. Here it's showing like a half screen being your face. I don't know if you can see these. Oh no, you may not be able to see them because of my head. But yeah, this guy has a lot of Microsoft related videos, so I'm sure his video is useful. Oh yeah, so you say, can you see it because of my head? Let me change the scene. You say insert, and then I think you say your face. You go to insert cameo, and then you select the icon to be whatever you like. And it looks really nice, because like there is a I know, yeah, it's like, don't you dare use Zoom. Because you know, you can, on Teams, you can just share the slide really cool if you are using Teams at work. And then if you insert yourself inside, you don't have to turn on the camera from Zoom. And yeah, you can probably act like King Kong or something. Like, I'm eating the PowerPoint. Yeah. Again, I have not used it yet because I feel like it's a bit cheesy, but maybe someday. It looks cool though. I'm sure it's useful. There's a thing I found when I was just testing it. Like it was a wobbly circle, not a circle. It looked like it was drawn by a kid, and then it had a board. I said that wrong. A line outside it that was, again, looked like it was drawn by a kid. I really liked it. I don't think I've used PowerPoint since university. Oh, okay. Mine was also a long time ago. Yeah, each time I see high school kids graduating, I'm like, mine was way too long ago. But I have actually used PPT recently for work-related purposes. If I recall, there's a jockey video from an MIT student about using PowerPoint. Really? What do you mean Turing complete? Do you mean like Alan Turing related? I have not seen that. I don't know what you mean by that. And if you think it's stream acceptable, I could play it, but if it's not, then I might not. And there's a dog barking. I mean, I don't need to say it. You guys can all hear it. Sorry, CMU, not MIT. No. Very on topic. This is CMU. Does our professor know about it? I will ask one more time. It's long? Okay. How stream acceptable is it? Like, is it appropriate? 5 minutes is not that long. I'm curious now. I'll pause it if it's if anything happens. 7 years ago. Wow. It's from... Okay. Music is interesting. Do I need to read it out loud, or are you guys able to see it? You are able to see it. Means the computer can compute an impossible calculation given him enough time, I think. Okay, thank you. Needed to be reminded of that. All right. All right. Can we use PowerPoint to edit images? Why not? One slide to the other? Improve. Oh wow, Comic Sans. Can you see that? You can see that. Oh, you're watching one. That was funny. Oh wow. Oof. Can we use it to do everything? Alright, let's see. Introducing. PowerPoint. TM. Oh, okay. TM is a trademark of Alan Turing. This is a trademark of as in teachable, no way. Teachable machine, no way. What is that? And TM is a trademark of me. Because, okay. TM. Fun.
Hello, my name is Tom, and in this presentation I will present my breakthrough research on solving computational problems using PowerPoint. I will explore to what extent PowerPoint can replace conventional programming languages, as well as the benefits and limitations of using PowerPoint for such purposes. But first,
Turing machines, wow. Okay, brain does not compute yet, okay? Don't blame me.
First, a quick disclaimer. This presentation is not sponsored or endorsed by any real or hypothetical corporation located in Redmond, Washington. The views and opinions expressed are those of the author and do not necessarily reflect those of any such corporation should one exist. Only trained PowerPoint professionals should attempt to reproduce the results of this research, and the author will not be held responsible for any material, physical, or emotional damages caused by such attempts.
Okay, not responsible
So with that
for
out of the way, we
emotional.
can proceed to the background. So as you may know, PowerPoint has hyperlinks and animations, which can be used to add interactivity to your presentations. So we have links here, and then we also have animations, which are particularly interesting because you can trigger them in different orders. So you can use these to make interesting things, like applications, games, typical things that you'd make in a slideshow editor. But until recently, it has been unproven as to whether you can do all things using PowerPoint, whether you can solve every computational problem with a dedicated PowerPoint file. And this is largely because in order to prove such a claim, you would need to create a Turing machine that runs in PowerPoint, or you'd have to be able to show that every Turing machine can be run within PowerPoint. So without further ado, the palindrome recognizing Turing machine.
I have a question. How long is his PowerPoint? Like, my limit is 10 slides. Over 10 slides, then everyone is asleep. But not here.
So here we have a Turing machine that decides the language palindromes of even length. So you can see that, like a normal Turing machine, we can move this tape. This is implemented completely with animations. There are no macros or anything else.
Why?
So I can write to the tape, of course, so we'll give it a simple input like this. And of course, I can also execute the Turing machine. So here we have the Turing machine's current state, and in order to continue execution, unfortunately this doesn't happen automatically, it needs a little bit of encouragement. The user has to click on each orange region. Now you might be concerned here that I'm making decisions whenever I'm clicking on this, but the way that this PowerPoint is set up, every other area is blocked. So I can click randomly essentially, and the PowerPoint will just advance its computation. So that was the input 1.1, so this should end up being accepted, and we can see that it does indeed end on an accepting state, and I could rerun that with another input and it would reject accordingly depending on what it is. So this is nice, but what we'd really like to be able to do.
Oh, okay, so it's all animation and it's only 13 slides. Wow. The original Turing machine had a paper. Yes, I know. I haven't read the whole thing myself, but I do believe you are. Yeah, that's the thing. Paper tape of infinite length. Yep.
Is run any Turing machine in PowerPoint. Fortunately, This is easy because the PowerPoint Turing machine is programmed entirely using punch cards. So for example, this card says that whenever the Turing machine is in state 0 and it reads a 1, then it should write a blank, move to the right, and then move to state 2. But if we change where these holes are located, we can make the Turing machine do something else and essentially imitate any transition function of any other Turing machine. All of this is accomplished using over 1,600 animations and around 700 auto shapes. The PowerPoint Turing machine offers a number of advantages.
Someone had a lot of time on their hands, didn't they? What? It is terrifying.
For alternative programming languages, offering cross-platform support, running on both mobile devices and both commercially relevant desktop operating systems.
Oh
In
no.
addition, its drag-and-drop program
No Linux. You're sad. You're missing out on this unusual technology.
means there's no text and no syntax errors. But most importantly, you can use themes, word art, and transitions that PowerPoint is infamous for in your code.
Wow.
It requires asymptotic
I would love to have my comments be word art. Who doesn't want that?
fewer auto shapes than when implemented in alternative slideshow editors, definitively proving PowerPoint to be exponentially more capable than competing software. But perhaps most notably,
I agree.
the PowerPoint Turing machine shows that the PowerPoint iOS app is in violation of Apple's App Store guidelines.
How
It
come?
shows that PowerPoint can emulate alternative apps and execute arbitrary code. In the future, I'd like to research making PowerPoint code more scalable
No.
and optimized,
No.
so that one day, every application you run on your computer can be run within PowerPoint.
That was fun. Now I'm scared for the future of humanity, if such people exist. They have too much power. Point. Wow. You know, committing to the bit. This is committing to the bit. And that was 7 years ago. PowerPoint has gotten to a new level now. I seem to remember being a longer version, like a talk that maybe this was only 5 minutes. Yeah. With details on how to recreate it for those who have too much time on their hands. Whoa. If this was not like a end of year project and just a normal project, like good job, kid, for having, like, for finishing it, honestly.
On any dataset. You can also undo final data processing
Why did I lose the CC? Trainers. Back with trainers.
such as dynamic padding, as long as you provide the tokenizer or a given data collator. We'll try this API provides
Do we need to give everything? So, okay, data, fair. Model, tokenizer, data collator, and hyperparameters and metrics of evaluation. Okay.
the tokenizer or a given data collator. We'll try this API
Too much effort, too much. Apparently, SIGBO, isn't that like a joke? Contest. Like questionable computer science projects. That is really cool. That, like, people that finish their stuff early, that gives them motivation to work on useless things that they will learn stuff from, right? Such things really should exist in other places as well, because it just brings out creativity of the students. Because sometimes projects feel like they're sucking the life out of you. Yeah. Imagine finishing something before the last minute. I know. Who would do that? No. I'm sure you've seen the TED Talk where the guy is saying how procrastination can be useful, and people who wait till last minute have like a, you know, leg up or something, because you worry about it and think about it, and then I don't know. There's a TED Talk about it. I wish I could do things on time. Yeah. Yep. Happy. I think not having deadlines is like, without deadlines it's hard to do things on time. Hi Sabir. Easiest way to solve the problem. Are we talking about the PowerPoint video we just watched? Because there are easier ways. I am noticing that you guys cannot see the gerbil in my pocket, and I'm sad about it. I wonder what PowerPoint CMU student was procrastinating about not doing when he made that. Yeah, probably. Probably something simple, more simple than that. Last minute work. Yeah. You know what? Yeah, thank you. Regarding last minute work, sometimes when you have a lot of time, you figure out a lot of avenues to research and all that, but when it becomes last minute, you cut out a lot of useless things, and you're like, you know what, this doesn't serve me, I'm not even gonna waste time on it. So yeah, it might have been a group project, probably. I don't know. I don't know if you can convince people to work on something like that. Maybe they are a group of people that can be convinced. Yeah. His teammates might have been like, where oh, you mean he ruined the group project? That makes more sense. I agree. Yep, the bird seems to agree as well. So we're going to use the same thing we were using, which was made for sentence pairs. Okay. It was not summarization, but it was something close.
Yeah, in the MRPC dataset, since it's relatively small and easy to preprocess.
Okay.
As we saw in the datasets overview video, although we can preprocess it. We do not apply padding during the preprocessing, as we will use dynamic padding with our data collector with padding.
I saw that also using padding later, and I was like, now I understand that. See, this is padding later, not padding before. So that made me happy that I understand the code a little bit more.
Note that we don't do the final steps of renaming, removing columns, or set the format to torch tensors. The trainer will do all of this automatically for us by analyzing the model signature. The last step before creating the trainer are to define our model and some training upper parameters. We saw how to do the first in the model API video. For the second, we use the training argument class. It only takes a path to a folder where results and checkpoint will be saved. But you can also customize all the upper parameters the trainer will use: learning rate, number of training epochs, etc. It's then very easy to create a trainer and launch a training. This should display a progress bar, and after a few minutes, if you're running on a GPU, you should have the training finished. The result will be rather anticlimactic, however, as you will only get a training loss, which doesn't really tell you anything about how well your model is performing.
That's why we need a metric.
Because we didn't specify any metric for the evaluation. To get those metrics, we'll first gather the predictions on the whole evaluation set using the predict method. It returns an M tuple with 3 fields: prediction, which contains the model predictions, label IDs, which contains the labels if your dataset had them, and metrics, which is empty here. We're trying to do that. The predictions are the logits of the model for all the sentences in the dataset, so an array of shape 408 by 2. To match them with our labels, we need to take the maximum logit for each prediction to know which of the two classes was predicted. We do this with the argmax function. Then we can use the metrics from the datasets library. It can be loaded as easily as a dataset with the load metric function, and it returns the evaluation metric used for the dataset. We can see our model did learn something, as it is 85.7% accurate. To monitor the evaluation metrics during training, we need to define a compute metric function that does the same step as before. It takes a name tuple with predictions and labels, and must return a dictionary with the metrics we want to keep track of.
Okay.
By passing the epoch evaluation strategy to our training arguments, we tell the trainer to evaluate at the end of every epoch. Launching a training inside a notebook will then display a progress bar and complete the table you see here as you pass every epoch.
That's pretty. Okay, so I might have understand like 25 to 30% of what he discussed, but I do believe the rest of this is going to be a repetition of that. So I am hopeful that I will hopefully understand a bit more. I do think I need to open a new collab, like just copy this again, and not continue on the other one. There you go. Thank you. And then zoom in a bit more. Okay. So the HuggingFace Transformers library provides a trainer class. Why did I think it was a library on its own? Okay, it's part of Transformers. To help you fine-tune any of the pre-trained models it provides on your dataset. Once you've done all the data pre-processing work in the last section, you have just a few steps left to define the trainer. So the hard part is the data preparation. Okay, the hardest why do I look like a text generation model? Because like I ended there and I was like the hardest part, and then now it's saying the hardest part is likely to be preparing the environment to run the trainer.train, as it will run very slowly on a CPU. If you don't have a GPU set up, you can get access to free GPUs and TPUs on Colab. Yup, I think you have to actually select it manually somewhere around here. There. If you don't, it assumes you want to run it on CPU. The code examples below assume you have already executed. Hey, how rude. I just closed the other collab. There, now it's opened. Okay. So, assuming I've already ran, which parts? Which parts? Not that one, that's for sure. Oh no, not that one. I'm gonna delete this because that's not relevant. Yep, the dog seems to agree with me. I'm guessing these parts. They're now a group. I'm sure they're bullying something. Sorry. So do I change to GPU now And then do I need to run everything again? I have no idea. I'm gonna do it just in case. Do we? I'm just gonna say run before and see if any errors happen. So, here's a short summary recapping what you need. Oh my god, I should have read that before I did all of this. Okay. So we are loading the data set, the tokenizer, and the collator with padding. Each time I read the with padding, I think of shoulder pads. I don't know why. So we have the data set, we have our checkpoint name, and then we load our tokenizer saying from pre-trained, and then we have to make a tokenizer function so that we can call it in the map part, and finally we just give the tokenizer to the data collator with padding so that the padding happens post tokenization to save time. I'm guessing that's all we need, so I'm just gonna go, yay, we have an error, and I'm not gonna care because I have everything here already. Good. That's good. Kill the other one, murder it. Do that. Terminate. And then run this one again. Double checking run time. Okay, will it work? We will never know. But we can try. Okay, while you do that, I'm going to go to the next part, which is the training. To prepare for the training, let's see what we need. The first step before we can define our trainer is to define a training argument with an S. Okay, training arguments class that will contain all the hyperparameters the trainer will use for training and evaluation. The only argument you have to provide is a directory where the trained model will be saved. So that's the only required one, but you can also make changes to other stuff. Okay, as well as the checkpoints along the way. For all the rest, you can leave the defaults, which should work pretty well for a basic fine-tuning. Too basic. So alright, so we've loaded everything. Our pre-processing is done. Now this is just the name of a folder, right? In here. So if I run this, does it sure. Is that the issue with me using GPU? Should I try CPU? Because I've seen this way too many times. And each time I say update, accelerate, and install and all of that, it's like its requirements are already satisfied. See? I've seen this before. This is deja vu. I might need to... I'm gonna run both just to be extra careful. And I do hope it's due to missing packages and not because it's being mean to me. But let's see. Okay, while you do that, if you want to automatically upload your model to the hub during training, pass along push to hub to be true in the training arguments, assuming you've already done the login part, right? Always one step ahead with the issues. Yeah, being worried little piece of anxiety is helpful sometimes. And then I remember that I shouldn't be too worried. No, we're good. Gemini, what are you doing here? Okay, that part's done. Again, everything's already there. I know. I might need to go back to CPU. Let's see. Oh, you're done? Happy? Oh, it always requires a restart, doesn't it? Restart session. Yes. And then run everything again. Did we restart? Okay. I'm gonna just run the things that I needed to run, which is... I guess I don't need this, right? I shouldn't. Why are you quiet? Say something. Okay. And then you next. You ran. Oh, it worked! Is that a refresh? Yes. Okay. So next, the second step is to define... I guess a restart was necessary? Was that it? The second step is to define our model. As in the previous chapter, we will use the auto model for sequence classification class with 2 labels. Because we have 2 labels. And checkpoint is the name that we already defined up here, which is BERT base uncased. Okay, so we're just calling our model. Model, come here. And then you will notice that, unlike chapter 2, you get a warning after... Oh, we do? Okay. Instantiating this pre-trained model. This is because BERT has not been pre-trained on classifying pairs of sentences. So the head... okay. Of the pre-trained model has been discarded and a new head sustainable for sequence classification has been added instead. So it recognizes it and changes the head which says which task it's doing. The warnings indicate that some weights were not used, the ones corresponding to the dropped pre-training head, and that some others were randomly initialized, the ones for the new head. It concludes by encouraging you to train the model, which is exactly what we are going to do now. So this is what's happening here. Some weights were not initialized. Classifier bias, classifier weight. You should train this model to be able to use it for predictions and inference. Okay, that's what we're going to do. Once we have our model, we can define a trainer by passing it all the objects constructed up to now. The model, the training arguments, which technically isn't anything, the training and validation datasets, our data collator, and our tokenizer. So we just give it that. Okay, these are like, here, look at them, but these are like, you know what they are. You don't need me to tell you what they are. Note that when you pass yesterday, wait, BERT is trained on sentence pairs? Yes, they weren't. BERT wasn't. I don't remember that, but it seems reasonable. And now we are training it on sentence pairs. Did we get a number yesterday of how good it was? And can we optimize that, like make it better? So note that when you pass the tokenizer as we did here, the default data collator used by the trainer will be a data with the padding, yeah. Oh, wait, what? Oh, yeah, we have it. So? So you can skip the line. Why? It will still... Wait, why? The default one that's used by the trainer will be... Oh, it already is using that, I see. HuggingFace really checking that we are paying attention with these M. Night Shyamalan twists. Yeah? Okay. Oh, speaking of which, M. Night Shyamalan's daughter is making a movie. And I recently read the book as a preparation to watch the movie. Why? Because it has Dakota Fanning. And I love Dakota Fanning. That's the only reason. The end. I think it's called The Watcher or The Watchers. Something about watching. Yeah. So, to fine-tune the model on our dataset, we just call train, and that's it. So, you cannot send this because it's already default, but sending it makes your heart, feel better. So do that. Do I need to ask if you can hear the chickens? I feel like I'm being exposed right now, and I'm not comfortable. Now they're quiet, because I called them out. Okay. Wow, training is pretty fast. And then the rooster is like, my time to shine. Well, Mr. Rooster, the sun's already up. It's too early. I mean, too late. Ah, there we go. Half an epoch is... Oh, there's the folder. Because when I ran this line, I was like, where's my folder? It didn't create it then. Now it's creating it. Okay, you do that. I just want to see Epoch 1 being finished so that I can see that line. No? Oh, it doesn't show automatically. We have to wait. I expected better. Okay, so this will start the fine-tuning, which should take a couple of minutes on a GPU. Yep, it should take, let's say 2 minutes. Oh, here it is. Huh. It's just training loss, and then we will update that to be more humanly understandable. Okay. This will start the fine-tuning, which should take a couple of minutes on a GPU and report the training loss every 500 steps. Because we said that somewhere. We did not? Is that by default? Okay. It won't, however, tell you how well or badly our model is performing, because we did not tell the trainer to evaluate during training by setting evaluation strategy, fancy, to either steps, evaluate every eval step, or epoch, evaluate at the end of each epoch. Okay. We didn't provide the trainer with a compute metric function to calculate a metric during said evaluation. Otherwise, the evaluation would have just printed the loss, which is not a very intuitive number. Okay. I know normally you just say, like, I guess I can't compare it with Whisper, but you just say, there it is, actually, metric. Like, for example, this is word error rate. That's it. and then you have it. And then look, compute metrics. Oh my god, I am understanding this better. And I am happy about this. Where are we? Ooh, this is going down. Loss is going down. That's pretty good. We have 26 seconds remaining. Let's prepare for the evaluation. So, let's see how we can build a useful compute metrics function and use it the next time we train. The function must take an eval prediction object, which is a named... Do I say tuple or do I say tuple? Because I still don't know how to pronounce this. And you might be like, who cares? I do, for some reason. Tuple. It's... Oh, no, tuple is British and tuple is American. Nope, it's both tuple. Got it. Practice? No, just read it for me.
Tuple.
Tuple, okay. Which is a named tuple with a predictions field and a labels ID field. Okay. And it will return a dictionary mapping strings to float, the strings being the names of metrics returned and the floats being the values. Okay, fair. To get some predictions from our model, we can use it again? Oh no, okay. Trainer.predict command. Wait, so 3 epochs, 2? Ah, because every 500 steps, and it was 1,377 steps. And this is some interesting stuff. Training loss. Wait, why is it 0.31 when the last one was 0.26? Oh, we have some metrics. Running time was that many seconds, I guess. Sample per second, 49. Training step per second. Every 6 seconds, it advanced a step. Okay. I don't know what flows is. And then the loss. And then epochs. We had 3 epochs. I don't think we even told you how many epochs you should do. And then for the prediction, trainer.predict, based on the validation dataset, we're looking at shape of the predictions and then shape of label IDs. I don't know how useful that is. Like, okay, 408, what does that give me? I don't know. So the output of the predict method is another named tuple with 3 fields: prediction, label IDs, and metrics. Where's the metric? This one? The metric field will contain the loss on the dataset passed, as well as some time metrics, how long it took to predict in total and on average. Once we complete our compute metric function and pass it to the trainer, the field will also contain the metrics returned by... I don't know what you mean by that, but we'll try. Okay. As you can see, predictions is a 2-dimensional array with a... Yep. So that's information inside. 408 being the number of elements in the data set we used. Okay. Those are the logits for each element of the data set we passed to predict. As we saw in the previous chapter, all transformer models return logits. Yes, that's true. To transform them into predictions that we can compare to our labels, we need to take the index with the maximum value on the second axis. To transform them into predictions. Okay, so am I doing the argmax now? And numpy argmax. We're taking predictions. We're saying second axis. So does -1 mean second? I thought it meant last. Okay, I guess we have our predictions, and then we need to make sense of them. We can now compare those predictions to the labels to build our compute metrics function. Hold up, do we have one with an S and one without an S? Why does this one have an S and this one doesn't? Are they different? Okay. We will rely on the metrics from the HuggingFace evaluate library. We can load the metrics associated with the MRPC dataset as easily as we loaded the dataset. This time, with the evaluate.load function, the object returned has a compute method we can use to do the metric calculation. Okay, so we say evaluate load, here's what we used, and then we say compute, this is our predictions, which we took from, let's see what we did. We said trainer predict based on the validation, and then we said numpy argmax our predictions, and then with the axis, and finally we're giving it that with the label IDs as reference. That sort of makes some sense. Okay, now we have accuracy and F1. Accuracy is 0.84, and then F1 being 0.89. So we have accuracy, recall, F1, right? I forgot what they were, but they have to do with false. I mean, I forgot the actual formula. Yeah. But they have to do with false positives, negatives, true positives and negatives, and those stuff. So the exact results you get may vary. They are. The accuracy was less than this. As the random initialization of the model head might change the metrics it achieved. Here we can see our model has the accuracy of 85% on validation set and F1 score of 89. Whoa, yours is higher than mine, isn't it? Okay. Those are two metrics used to evaluate results on the glue benchmark. Okay. The table here in BERT reports an F1 score of 88.9 for the base model. That was the encased model, while we are currently using the cased model, which explains better results. I have no idea what uncased and cased model means. We can do a quick Google, because I want to know what they mean. Okay, I read somewhere case models should only be used when there's a chance that letter casing will be helpful. What does letter casing mean? I am working with German text. Cases. Like capped. Oh, yep. Difference tokens with different cap. Thank you. There are two models, for one where one sees cases and one doesn't. That is interesting. Good thing Arabic doesn't have cases. Wait, is having cases like capital and small only for, is it correct for me to say Latin languages? Very interesting. Where were we? We are here. Okay. Wrapping everything together, we get our compute metrics function. So, that is better. So, the things we did upstairs, I guess, it can be, hold up. Carjack, Jack being name or, yeah, I guess. Okay, that makes sense. Can be of help, maybe. Fair. No, I was just thinking, why do we need two models? Can't we have something like from the beginning to say, I don't know. I don't know what I meant, but I'm just saying, like dialects. Can we have something that recognizes the dialect and then chooses based on that? But I don't think that's like, if you give it sentence of small without Gen Z written text, I don't know, maybe all we know is that they didn't do that for Bird. Okay, fair. Maybe others can recognize it without needing to be told. Good point. Very good point. Like different prefixes. I'm sure something about the subword tokenization helps with that as well. Maybe. So putting it all together, the loading of the metric, the giving it the look here, we're saying label and then logits, and we are getting the eval predictions, and then we are giving the logits to the argmax with the axis, and then putting that into the metric dot compute predictions and labels. Labels came from here. I do want to go back and look at what we wrote, which is, this is the prediction. It has predictions and label IDs, and the predictions are the logits. Okay. So put them all together. We don't have to. We already did some of the stuff, but let's do it again. So that we train again with... Oh, we are training again. Okay. I'm gonna let it train so that it doesn't take too much time while I continue the learning part. And you see it used in action to report metrics at the end of each epoch. Here is how we define a new trainer with a compute metric function. So we just added one more line, and it is our function that we prepared. Note that we create a new training argument with its evaluation strategy to set epoch and a new model. Otherwise, we would just be continuing the training of the model. We have already trained to launch a new... Yeah, we have to give it the arguments. Yes. We just execute trainer.train, and while that happens, I do want to see if we have any... Why don't we have anything reported yet? It's been 400 epochs. Oh, there's one. Yay! Not 400 epochs. One epoch. It's this one steps. This is epoch. You're on time. So we have training loss, nothing. Validation loss, 0.37. Accuracy, 0.85. F1, 0.9 already? That's pretty high. Let's see if it improves or not, because sometimes it gets worse. Okay. This time it will report the validation loss and metrics at the end of each epoch on top of the training loss. Again, the exact accuracy F1 score you reach might be a bit different from what we found because of the random head initialization of the model, but it should be in the same ballpark. The trainer will work out of the box. It will work out. The trainer will work out of the box on multiple GPUs or TPUs provides lots of options like mixed precision training, use FP16 to true in your training arguments. I don't know what that is. Okay, we'll go over that in chapter 10. We're in chapter 3, no? This concludes the introduction to fine-tuning using Trainer API. An example of doing this for most common NLP tasks will be given in chapter 7. For now, let's look at how to do the same thing in pure PyTorch. Whoa! Really? I'm not gonna try anything else out, okay? I don't think I have the energy to. That's pretty long. That's a full day of stream. I will give you all of my heart, but later, not today. F1 is going down, accuracy is going down, as expected. It was too high. Okay. Another epoch is on the way. 15 seconds left. While that happens, I'm going to refresh this, otherwise it will refresh on its own and sometimes annoy me, but not always. So, we're done. We ended somewhere where we started, but that's because of data. Sometimes if recall value is too high, then it's overfitted, so it's a good thing that it went down. Loss went up? Why? Is that a good thing? I don't know. I forgot. Anyway, I still want to do one more double check of what we did, which is, where do we start? Hold up. Where's the first thing that there it is. Okay. Can I zoom in to make it more? There it is. There. So, that should be more readable, right? So, we loaded a data set from Glue, which has this MRPC task, I don't know, and it's sentence pairs. Those sentence pairs are either, I think there are two labels, like entail, contradiction, stuff like that. I think might be wrong. And then we are saying use this checkpoint of the model. We call this hi. The Luke is here. The Luke. How is learning going? Better than expected. Like, I can't say. I don't know. Like, I think I understood all the steps that we did today up until now, and you're lucky because I'm just doing a recap of the first part of the stream, which is like now, up until now. The second part is upcoming. What we learned, which is how to fine-tune, like a simple hello world of fine-tuning a model on HuggingFace. So we need to have our data, which is the raw data set, loaded, and then the name of the checkpoint, you can just put the name here, but just calling it here, you can use it for the model a few steps down. We load the tokenizer, saying auto tokenizer from pre-trained, and then we create a function for the tokenizer because that way we can use it with the map, dataset.map, and then say batch. I think that makes it faster. Here we are giving it, since this is I think tokenizer expects is okay with having two sentences. Normally it expects one, but if you give it two, that's also something that it can do. And then you're saying it truncate, I think based on the default of the tokenizer. And then we do the mapping, which is for the rest of the data set. Then we do the padding, because if we say padding true here, it will be costly resource-wise. That's it. That's the only reason we have this line. Yeah. And then I did some of these, not necessary, but without doing them you get errors. We are getting training arguments. That was loud. Okay. Training arguments, for now we're just telling it where to put the output. Just we gave it a name of a folder, and we can look at what's in there. And we are calling our model auto model for sequence classification from pre-trained. We are saying this is what we want. We got checkpoint name for tokenizer, checkpoint name for the model, and then number of labels equals 2. I'm not sure why we are saying that, to be honest, at that point, but maybe we're saying how many outputs of the tokenization there are, not tokenization, classification. Maybe. Okay. So then we'll get our trainer class, give it the parameters. I don't know if they're called hyperparameters. Are these hyperparameters? Because this is arguments. If I call these arguments, might be confusing. So we give it the model, our configuration, the data, like just call the data set that you, tokenized data set that you have, training and validation. And here we're missing something, but it's alright. Data collator for the padding and the tokenizer. The thing that we're missing is how it should do the evaluation, because here the output is not really useful. To do that, we make this function that says this is what I want the metric to be, like we're just loading it from the data set. Another one would be just like naming the metric you want. Another example is like here, this is doing word error rate. Then we have from the evaluation prediction that we're getting, we're taking logits and labels. Logits go to the NumPy argmax, and then the labels go to metric.compute as a reference. And then we train it, and then this is the output we get. Yay. Yeah, so these are the steps: data, tokenizer, metric, what else, model. Yeah, that's about it. The data collator is still a part of the pre-processing of the tokenizer, and then the training arguments, we didn't really do anything about them. If I go to the folder, we have checkpoints with a lot of information. And then vocab, we have vocab. Oh, careful. Can I open this? What is that? Oh, this is actual vocab. Okay. Grim, Malaysian, rigid, publicity. Fun. And then we have runs. We ran it multiple times, did we? Okay. Okay, all right. I'm actually trying to somehow so true, we have the best viewers, and now I sound like some leader, which I don't want to sound like. I forgot. Block? Ban? We can ban them. Banned, woo! There. So, vocab is tokenization mapping of token IDs to words. Yeah. Should be. And they're just numbers. Like it's a numbered list. Which, yeah, ordered, numbered list. Woo, what is that? Interesting stuff. Hold up, is there anything non-English? Of course there is. Wait, no? Oh, wow, look! Letters! Letters of different languages. Woo. What else is there? Indian, I think. And then... hunger. Korean, anyway. And... math. Our vocab is pretty big. 30,000. Cool. Okay, so now we're going to give our brain some rest by learning more. Yeah. This is part 2. Part 2, begin. Okay. There will be times where I mute myself. Do let me know if you need anything so that... Yes. Let's see.
Cool. Another thing that maybe I should mention, so this doesn't sound completely outdated. There was a really good paper recently that used the fact that n-gram...
Question. How's the voice? Should be similar to mine, but it still feels like he's far away. Yesterday I noticed he changed his microphone. He's not giving us the output of the microphone, only the class is hearing them, and that made me feel jealous and left out. Yeah. Now my microphone is better. Missing the noise check thing, but now I can judge people.
Grams are so uses the fact that n-gram models are so scalable. It's this paper. It's called Data Selection for Language Models via Importance Free Sampling. And one interesting thing that they do in this paper is that they don't actually
Thank you, Luke. Thank you. I'm someone that cares way too much about audio because sometimes I just watch YouTube videos in the background. And the people that do all of the work with the editing, I feel bad, but at least I'm giving them a view.
Use neural models in any way, despite the fact that they use the downstream data that they sample in order to calculate neural models. But they run n-gram models over lots and lots of data, and then they fit a Gaussian distribution to the n-gram model counts, basically, in order to select the data. And the reason why they do this is they want to do this over the entire web, and running a neural model over the entire web would be too expensive, so they use n-gram models instead. So that's just an example of something in the modern context where keeping this in mind is a good idea.
That is surprising. 2020, November 2023 paper using n-gram models. Okay.
Okay, I'd like to move to the next part. So language model evaluation. This is important to know. I'm not going to talk about language model evaluation on other tasks. I'm only going to talk right now about language model evaluation on the task of language modeling. And there's a number of metrics that we use for the task of language modeling, evaluating language models on the task of language modeling. The first one is log likelihood. And basically, the way we calculate log likelihood is, there's an extra parentheses there. But the way we calculate log likelihood is we get a test set that ideally has not been included in our training data. And we take all of the documents or sentences in the test set, we calculate the log probability of all of them. We don't actually use this super broadly to evaluate models. And the reason why is because this number is very dependent on the size of the data set. So if you have a larger data set, this number will be larger. If you have a smaller data set, this number will be smaller. So the more common thing to do is per word log likelihood. And per word log likelihood is basically dividing the log probability of the entire corpus with the number of words that you have in the corpus.
Oh, okay. I was about to say this is scaring me, but the fact that this is copied here and then it's this thing, still scary, less so.
It's also common for papers to report negative log likelihood, where because that's used as a loss, and their lower is better, so you just need to be careful about which one is being reported.
Mm-hmm.
So this is pretty common. I think most people are somewhat familiar with this. Another thing that you might see is entropy. And specifically, this is often called cross entropy because you're calculating you're estimating the model on a training data set and then evaluating it on a separate data set. On the test data set. And this is often or usually calculated as log 2 of the probability divided by the number of words or units in the corpus. Does anyone know why this is log 2?
No.
As opposed to a normal log?
Because we felt like it. Base 2? Something with base 2? I have no idea.
Anyone? Yeah, sure. Yeah, so it's calculating as bits. And this is kind of a...
Okay.
This is kind of a historical thing, and it's not super, super important for language models, but it's actually pretty interesting to think about. And so actually any problem...
Exactly. Something, something, information theory, something, something. Mm-hmm. We had it in undergrad. It was fun.
Probabilistic distribution can also be used for data compression.
Yeah, Klaus Schwanen. He's cool. I probably have read about his life, but now I remember nothing. Maybe like as a slide, not as a whole book. But yeah. There's a really fun book that I never got around to reading it. Then how would I know it's fun? I forgot what the title is even. Well, that's very interesting.
So, when you're running a zip file or you're running gzip or bz2 or something like that, you're compressing a file into a smaller file. And any language model can also be used to compress a file into a smaller file. And so the way it does this is if you have more likely sequences, for example, more likely sentences or more likely documents, you compress them into a shorter output. And kind of the ideal, I think it's pretty safe to say ideal because I think you can't get a better method for compression than this, unless I'm, not well versed enough in information theory. But I think this is basically the ideal method for data compression. And the way it works is, I have a figure up here, but I'd like to recreate it here, which is, let's say we have a vocabulary of A, which has 50%.
Oh, it's called the code book. I was researching it, and I found it, and it's called the code book. And I probably have read like only 10 pages, like 10 years ago. But it still is fun and interesting. It's about cryptography. And it starts from like, ancient Egypt to quantum cryptography. It's pretty fun. Yay. Now my attention is back. And I will go back 10 seconds.
Created here, which is, let's say we have a vocabulary of A, which has 50%. And then we have a vocabulary B, which is 33%. and a vocabulary C, C, which is about 17%. And so if you have a single token sequence, what you do is you can see, divide this into 0 and 1. So if your single token sequence is A, you can just put 0 and you'll be done encoding it. If your single token sequence is B, then 1 overlaps with B and C. So now you need to further split this up into O and 1. And you can see that let me make sure I'm getting that right. Yeah, you can see that
We can see that
1, 0 is entirely encompassed by B. So now B is 1, 0, and C is not entirely encompassed by that. So you would need to further break this up and say it's 0, 1 here, and now 1, 1, 1 is encompassed by this. So you would get C if it was 1, 1, 1. And so every sequence that started with 0 would start out with A. Every sequence that started out with 1, 0 would start with B, and every sequence that started.
I think I just noticed that this used to be down here, now it's up here. So you can see me and him at the same time. Lucky you guys.
With 1, 1, 1 would start with C. And so then you can look at the next word, and let's say we're using a unigram model. If we're using a unigram model for the next token, let's say the next token is C. So now the next token being C, we already have B, and now we subdivide B into A, B, C. B,
Not
A,
really
B,
following,
B,
and I feel
B,
like
C. And then we find the next binary sequence that is entirely encompassed by B, C, by this like interval. And so the moment we find a binary sequence that's entirely encompassed by the interval, then that is the sequence that we can use to represent that script. And so if you're interested in this, you can look up arithmetic coding on Wikipedia. It's pretty fascinating. But basically, here, this is showing the example of the unigram model where the probabilities don't change based on the context. But what if we knew that C had a really high probability of following B? So if that's the case, now we have like A, B, C here, like based on our bigram model or neural language model or something like that. So now this interval is much larger. So it's much more likely to entirely encompass a shorter string. And because of that, the output can be much shorter. And so if you use this arithmetic encoding, over a very long sequence of outputs, the length of the sequence that is needed to encode this particular output is going to be essentially the number of bits according to entropy times the sequencer. So this is very directly connected to like compression and information theory and stuff like that.
See? Wow. Conclusion, it's connected to information theory and stuff like that. We were already there. He had to, do all of this to come where we are.
So that's where entropy comes from. Are there any questions about this? Yeah. For C.
The student asking the question, doesn't it sound like it's coming from the wop 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 of the why did I forget the name of the cartoon? The bald guy. I know. They need to do all of this to get to where we are. Meme. PNG.
So 111 is because, let me see if I can do this thing.
Older
So-
Francis old. Oh yeah, Snoopy. There we go.
Okay,
Peanut. Yep. Yeah, it sounded like that just a bit.
1. So here, this interval is 1.
Mm-hmm.
This interval is 1, 1. This interval is 1, 1, 1.
Mm-hmm.
And 1, 1, 1 is the first interval that is entirely overlapping with C. And it's not 1, 1, 0, because 1, 1, 0 is overlapping with B and C.
So in which case will so in which case will you 110 to represent?
When would you use 1, 1, 0 to represent something?
That's an odd question.
It's a good question. I guess maybe you wouldn't, which seems a little bit wasteful. So let me think about that. I think it might
Oh,
be the case that
alaikum
you just don't
assalam.
use it.
Hi. You got here. Hi. Good morning, I think. Umayma, right? Yeah. I hope you are having a blessed Friday. It's Friday.
But yeah, I'll try to think about that a little bit more, because it seems like you should use every bit string, right? So
Yeah. Look at us not waking up late on a Friday. Pat on the shoulder. Good job.
yeah, if anybody has the answer, I'd be happy to hear it. Otherwise, I'll take it. Cool.
Cool.
So next thing is perplexity. So this is another.
Oh, I'm perplexed. How long are we going to talk about this? Okay. Cause my brain is like overheating. I have time though. I have 10 more minutes. Okay. Let's go.
One that you see commonly. And so perplexity is basically 2 to the per word entropy, or e to the negative word level log likelihood.
Word level log likelihood. Not will. Word level log likelihood. Okay. Maybe all those non-English characters are a bit arithmetic coding, like from the vocab.txt. File produced from the HuggingFace lecture. Interesting note. I guess. I can't say I understood the arithmetic coding, like with something that I could repeat. But I also see how you are trying to help me understand it. Like the English words were coded. Less common foreign words were represented as letters. That's true. That did happen. And isn't that basically what subword tokenization is? Frequent ones, take them as they are. Less frequent ones, chop them apart. I mean, I don't know if we get to the letters, but yeah, that now I understand what you meant. Thank you. Play? Okay.
Space. And word level log likelihood in log space. And so this larger tends to be better. I'd like to do a little exercise to see if this works. So like, let's say we have when a dog sees a squirrel, it will usually, can anyone guess the next word? Just yell it out. Bark, okay.
Good question. I doubt I could, so this is log likelihood, not, I mean, likelihood. I will try to answer you by looking for it, because to be honest, I don't think I can answer you directly. Let me look for log likelihood function. And then, okay, likelihood function is something on Wikipedia, which is good. It's Bayesian statistics. That's interesting. And it has to do with probability, so let's see. The likelihood function is a joint probability mass. Gives probability discrete random variable. Okay. Probability density. Huh. Okay, that makes some sense. Why is it called a PDF? Of observed data viewed as a function of the parameters of a statistical model. The function is probability of observing data, assuming that's theta, right? Is the actual parameter. Isn't it supposed to be like, what's the likelihood of something happening? Just probability? I don't know. Oh, we have an answer. Just from Google result, thank you. Is a fundamental concept in statistical inference. It indicates how likely a particular population is to produce an observed sample. That is very more useful. That is pretty useful. Because this is way too technical for my liking. And too many English math words that I, for some reason, don't know. I learned math with X and Y, but with less English keywords. So yes, the likelihood of particular population to produce an observed sample, which is what we do language modeling for in a way. I don't know. Okay.
Anyone guess the next word, just yell it out.
Huh? Oh, okay. When a dog sees a squirrel, it will usually run, as in chase it. What do you guys think would be the next word? Chase is not a one word, but I guess run towards it.
Okay. What about that? What about something else? Chase.
Chase, okay.
Run.
Math with X and Y algebra. Hey. No, I meant we used English, like things in writing. That's what I meant. Jabr. Yeah, Jabr means math, doesn't it? I think it does. I think Al-Khwarizmi, I think I tried to do some Googling last time with Al-Khwarizmi and Jabr. No need to apologize. Actually, like when I went to high school, math became X and Y. Before that, it was Sin and Sad, which is the Arabic equivalent. So I guess I'm lucky because, yes, Jabr is math. Thank you. Yeah. Because the more you get westernized, the better it is easier to be included in stuff. Okay, sorry, that was loud. I will mute myself if another loud thing happens next time.
Okay. Jump.
Jump. Ah, that's a good one.
Anything else? Any other ones? Ones. So basically what this shows is humans are really bad language models. So
Humans are bad language models.
interestingly, every single one of the words.
Oh, yeah, the ono part, it's alright. I learned math with X and Y too. That means you are probably young as well. I mean, I wouldn't call myself young, but like it started with me. So yes, I was in the trenches when it happened.
Words you predicted here is a regular verb.
Be, as in it will be happy, it will be mad, it will be and then jump, start, running, try, run. There's no chase.
But in natural language model GPT-2, the first thing it predicts is be, which is kind of like the copula. There's also start.
Be is lazy. It's a lazy prediction. More probably true, but also lazy.
And that will be like start running, start something. And humans actually are really bad at doing this, are really bad at predicting next words. We're not trained that way. And so we end up having these biases. But anyway, the reason why I did this quiz was because that's essentially what perplexity means. And what perplexity is it's the number of times.
I played a little with computers before seeing algebra. I thought they were variables. Yay! Aren't they though? They almost are, aren't they? Whoa, that's cool. Having access to a computer. I mean, I had access to computers early, but I didn't start with programming until 18. Yeah. Still, like being well versed in just usage of computers was very, very useful.
Times you'd have to sample from the probability distribution before you get the answer right. So you were a little bit biased here because we were doing sampling without replacement. So like nobody was actually picking a word that had already been said. But it's essentially like if you guessed over and over and over again, how many times would you need until you get it right? And so here, like if the actual answer was start, the perplexity would be 4.66. So we'd expect the language model to get it in 4 guesses, between 4 and 5 guesses. And you guys all did 6, so you lose to GPT. So another important thing to mention is evaluation and vocabulary. So for fair comparison, make sure that the denominator is the same. So if you're calculating the perplexity, make sure that you're dividing by the same number every time. You're dividing by words if the other paper or whatever is dividing by words. Or like, let's say you're comparing Llama to GPT-2, they have different tokenizers, so they'll have different numbers of tokens. So comparing with different denominators is not fair. If you're allowing unknown words or characters, so if you allow the model to not predict any token, then you need to be fair about that too. So I'd like to go into a few alternatives. These are.
I think I'm cutting my own foot by pausing here because it's alternatives to what we looked at. But I don't have the capacity to continue. I'm sorry. Rosenfield is one of... No, that's Rosenblatt. Different person. Okay. Thought I recognized him. Guess didn't. Whoa. We're only 3 lectures in. I was watching Mulan recently, so my brain is like, we have a long way to go. Yeah, okay. Yay, we did it. Now, class, what did we learn today? Is there any way? Of course. Discord is there. It's in the descriptions if you use Discord. You can contact me and ask me anything you like. And if you don't have a Discord, Twitter. If you don't have any of those, email. Machine learning courses have a lot of math. I feel like I need to take a refresher of algebra, calculus, probability. You feel that way, but I feel that way, obviously. But also, I'm like, you know what? Where to use it, when to use it, and not how is enough for me. Yeah, that's where I am right now. So if I made you feel small, I am truly sorry, Mr. Silent. Because I feel the same. Discord is good. Awesome. It's in the description. or linked somewhere around here. I really like this heart-shaped hand. It's cute. There's a possibility that the character can do it, but I have not hearted it, like I have not favored it, so it won't be easy for me to find it right now. It will look weird. But this is technically a half a heart shape. There we go. And now it looks weird because it's sideways. So I will try to let it wash over me. Literally, same. It's like the waves are hitting me and I'm like sitting still and let it happen. Just let it happen. But I have not been very hands-on trying to understand. Imagine me nodding and going, internally panicking. That is very true. Yeah. Internal panic. Life. So, thank you for Coffee, for Duhu, for Umeima, for Luke, for Mike. I think that's all the awesome, cool people. Oh, Sabir was here as well. For joining me in today's stream on this lovely Friday. Oh my God, you're still here. Get out of here. Get out of here. Please go to sleep. Sorry. It's like saying their name 3 times and they're here. I just said it once. Thank you. I wish you a lovely day as well, or night, whatever it is. Yeah. Have a lovely rest of the day. I'm gonna end the stream. Hope, yeah, you can do anything you like, as in join Discord. I don't know, other stuff that you can do if you want. You don't have to. And okay, those who are sleepy, please go to sleep. I will start my day, yes, with coffee and breakfast. Really appreciate you joining me for 2 hours. That's a lot of time. And for being here with us on this lovely day. I will end the stream. Oh no, you can't see my hands. Anyway, this is supposed to be a goodbye. Thank you for being here, and I'll do the from 5 to countdown. If there's anything else, thank you, Umeima. Let me know. Otherwise, see you tomorrow, inshallah. So if you feel like it, you'll see me tomorrow. There we go. So yeah, should be a lovely day with all those bird calls. I know. I mean, it's pretty hot though. Yesterday it reached 40. Yeah, it's hot. Yes. Sorry for bringing this reference in if you are not included, but the Seth Meyers corrections series, at the end each time he's like, see me next time, and when I said that, that's where my brain went. So thanks again. Appreciate all the cool people that I've met through this. It's quite surprising, honestly. Yeah, ending the stream in 5, 4, 3, 2, and 1. Thank you and goodbye.